Hello and welcome back. We're going to start today lesson number 4. And in this lesson, we're going to talk about strings. What are strings? Why we use them? And what applications that require accessing strings. And that's pretty much what this class is going to talk about. Basically, what we're going to talk about in this class is character pointers. And basically, that talks about how we access string of characters using pointers. And by now, we know what exactly pointers are and how to operate on these kind of variables. And then we're going to introduce some very common string functions. We're going to try to build some of them, and I'll leave some of these as exercises to you. However, we're going to explain in depth what is the meaning and what is the function of each of these functions to be developed. Okay, let's start. Strings. What is a string? Well, a string is basically a collection of characters that are stored in memory in contiguous locations. Well, memory in contiguous locations, that's nothing but an array, as you know. So a string constant is an array of characters that's stored in memory in consecutive locations. Each location contains basically a 1 character wide, 1 byte long character. So if this is my string, let me call it str, then this will be my string, and I can have any characters to be filled in here. However, this kind of array is very special, so that always implicitly, and you don't have to worry about this yourself, when you enter your string, the very last character is always the null character, which we have seen before. So the ASCII 0. Okay, so this is basically a string of 1, 2, 3, 4 characters that you enter, but actually the actual length, the actual size of it is 5 characters, as we can see if we take into account this null counter. Okay, so that's basically what strings are, and we have seen them, as a matter of fact, before. In the internal representation, the array is terminated with the null character. And we know this, and that's exactly what I was talking about when I was here. Example. If I define my character to be my string of characters to be something like car, str, okay, something like this, and then down in my program, if I say something like str equals a string, then actually what I'm doing in this case is that I'm reserving in memory this a contiguous block, an array of characters, to accommodate all of these characters, of course, including these spaces in here, which are the blank characters, as a matter of fact, so they count. So I'm reserving in memory enough location to hold all of these characters in a contiguous fashion, like that. So str is here, and then down here, I'm having this I blank, A, M, and so forth. Okay, so here's a picture of it if we go back to the screen. So car string, and we're initializing it right away in here, a string. So basically, str is a pointer, and we know pointers by now, that points to the first character in the string. Okay, so like I can see in here, here's portion of the memory which shows the string. I start with the letter I, that's the first character in the string, followed by a blank, then the rest of the characters consecutively, and the very last character always is the null character. So this big of memory is actually reserved for the string str. Well, as I said, strings can be accessed either through an array pointer or an array variable or as a pointer. And we have seen earlier that using pointers is much more flexible and much more easy. Actually, if you exercise on the pointers that I've already covered in previous classes, then you're going to find how easy to manipulate data using pointers. And that's what we usually do. And there is a lot of advantages for that, as a matter of fact. One of the very basic is that when we're using pointers, things run on the computer much faster. And that's because basically we're always dealing with a 4-byte pointer memory reference rather than dealing with the blocks of data. So I always refer to that location simply by referring to the pointer or to the address at which that block of data is actually located. So when I move from one place to another place, what basically I'm doing is I'm just moving the pointer to where this variable points or to where this pointer points, either here or there in the memory, and that's much easier. So access to strings is through a character pointer. So I define a pointer of type character, all right, and then I can assign to this pointer and the address of the specified string I want to access. So if I say something like car asterisk p message, then in this statement, what I'm doing, as a matter of fact, I'm defining a pointer called p message of type character, okay, and I'm not assigning anything to it. So I'm just reserving this p message as a pointer. All right, and then I can, after that, assign to this pointer or make this pointer point to any string, to any block of characters in the memory anywhere I like. And that's why we can say something like this. P message equals to this string. Now is the time. So in this case, P message will be pointing to the memory Here's P message. Okay, and it's pointing to the block of characters starting from N, O, and so forth till the very last character E, which comes here at the end, followed by, of course, the null character. The size of this block is actually depends upon the size of the string in here. So P message is gonna basically refer to all this block. As a matter of fact, it's gonna be pointing to the first character. It's just one pointer that points to one of the characters, and definitely it's the first character in the block. So simply, once I know what's the address of the first character, and I know that this block is contiguous in memory, then simply the address of this is basically whatever P message plus 1, and this is P message plus 2. This is the blank, P message plus 3, and so forth. So by doing this, I can go to any character within this string by just knowing the this address or the where this P message is pointing to. So this, as I say, assigns to P message a pointer to the character array. So I'm just assigning the address of this first entry. Okay, in C, strings in C, the definition of P message is not a string copy. Well, that's very important. What we mean by this is that I'm not copying anything into P message, but rather it's just a pointer that's involved in the operation. What does that mean? When I defined P message in the way I defined it a little bit ago by saying something like car p message, and when I said down there in the middle of my program p message equals to, now it's time whatever till the end of the string, I'm not copying this string into this variable, not at all. What I'm doing in this statement is that I'm just assigning this p message, this pointer, the address of the first character in this list of characters or in this string. And there is a big difference. And that's why we like to use pointers, as a matter of fact, because now p message is pointing to the whole string in a sense by referring to p message plus 1 and so forth, without having the hassle of copying the entire block of data of this string, placing it inside p message. Okay? So that's why we use actually in C to access strings, we usually use the pointers rather than using regular variables. C, as a matter of fact, does not provide any operators for passing an entire string of characters as a unit. Actually, in C, we only have functions, basic functions that operate on characters, single characters. So I can get a character, as we have seen this in other classes, in other lessons. We have seen how to get a character from the keyboard, how to display a character on the keyboard, on the display on the screen. So I can get string, get character, put character. I can assign a character from one place to another place, from one variable to another variable, and so forth. There are plenty of character-based functions in C, which allows me to assign characters here and there. However, there isn't any standard functions in C to manipulate strings. And that's the standard C, the ANSI C. So to do that, then we have to build our own functions based on the character functions, actually, because simply the string is an array of characters. So whatever applies for the one unit can be generalized to be applied to a block of these little units. So we can apply it to strings. And that's what we're going to do actually in this lesson. We're going to see some of the very basic functions that we can use on strings based on very basic, simple functions that are used for characters. Well, before we start working on these functions, let's look at very important notices and remarks. Let's look at the following two definitions. Char, a message, square bracket, equals, now it's time. In this statement, what I'm doing, I'm defining an array called a message, big enough. I did not assign the size of it in here because I'm initializing it in here. So this a message actually is an array in the memory big enough to accommodate the string, and it's of course of type character. Okay, let's see what do I have down here. Character asterisk p message equals the same string. What I'm doing in here, again, I'm defining a pointer that points somewhere in the memory to where I have this string. So what? Both statements sound the same at in conclusion. Well, not exactly the same. Yes, they both point to something like this. And in here, I have this string, now it's time, and I'm having the variable a message pointing to it. And this is an array. The other definition is something like this. Called p-message. Okay, and this is a pointer that points to the memory, to this starting address, which is the address of the in character in the word now, and then the rest of the characters. Well, basically, this sounds the same. That's true to a certain extent. However, if we look deeply into this, then we can figure out actually the difference between the two definitions. P-message is a pointer initialized to point to the string. So P-message is actually some sort of a pointer, a 4-byte unit which contains the address of the first entry in the characters set. Terminated, of course, with a null character always. A message, on the other hand, points, it is in a sense an address that points to the first entry in this block, which is now its time, terminated by the null character again. So pretty much we're talking about the same thing here. It's exactly the same thing as far as where these characters are stored as a string in the memory. No difference so far. Let's watch and see. Well, in a message definition, I can change these characters. I can go and make, now it's time, no, it's not, no, it is not time. I can do that, no problem with it. Basically, I can go to that array and change its contents the way I like. Of course, now I have the size fixed. So if you would like to change whatever characters, new characters you're going to add, they have to be of same size as the previous string, because that's already declared and you cannot have more characters. Excuse me. So then I can go into the memory and change the way I like in the characters. Okay, I can add new characters, replace some other characters, change the whole word, the whole statement that I have. That's all right. However, I can never change the value of this pointer of the array. So this address is fixed. Once I say something like car, a message, okay? Once I say something like this, then what exactly happens is that I go to the memory, and that's during the compilation step. And once I run my program, that's fixed. I go to the memory, reserve a block of data, and point to it by a message. And now this cannot be changed as long as my program is running. Okay? The next time you run your program, the same block is going to be reserved, but it could be at some other place. That depends upon the operating system and where it finds the suitable place to assign a message to. But as long as your program is running, you can never change a message. Okay? And that's exactly the main difference between this definition and the other definition. As we know, I can always, when I say when I define a pointer, I can always assign that pointer anywhere I like. And that's exactly the main difference between the two definitions. So a message will always refer to the same storage. However, I can change the individual characters within that. And that's very important. And that's the key difference between this definition and the p-message definition. P-message definition, on the other hand, the pointer may be modified to point elsewhere, of course. And we have seen this when we talked about pointers. I can always go anywhere I like and point to any location in the memory. Of course, as long as the operating system allows me to go to that location. Okay? However, if I make p-message to point somewhere else, then I'm afraid your original character set or your string is gone now. You cannot access it using p-message. And that's obvious. I mean, if I have something like this, and this is your pointer p-message, and you have your characters now whatever, okay? And in the middle of your program, you changed your mind and you decided to reassign this pointer to point to another block down here. Obviously, I can no more see this string, now it's time, or whatever data I have in there, because I'm going somewhere else now. And I assume you all know this, and it's very obvious and very simple. So yes, then with p-message definition, I can change, if you like, the location to where this pointer is pointing to, whereas in a message, the array definition, I can never change the actual address where the a message is pointing to. I can change the data itself, but I can never change the address. This is the key difference, and I want you to emphasize on this in your exercises. Okay, now let's see some functions that can be performed on strings. What can we do on strings? Well, we can do many things, and in real practice, there are many applications which involve dealing with text, and strings are nothing but block of characters and basically text. So what can we do? Well, in many instances, we would like to take a block of text, all right, and copy it to somewhere else. And we do that a lot. And at some other instances, we would like to check and see if a particular word exists in a text, in a page. Well, we need to compare strings. Some other times, I just would like to count the number of characters that I have in a block of text. And again, this is a very simple function to where I need to traverse my character set, my string, and just count the number of characters. Of course, you can count all characters, you can skip the blank characters, you can count number of words if you would like, and so forth. And this is actually very practical, and we use it a lot in word processing, in text-to-numeric conversions, in many applications, as a matter of fact. And maybe you have seen a lot of these applications in your real practical life. Okay, in this class, in this lesson, I'm just going to give two very basic functions to be performed on strings. And I'll leave other functions for you as an exercise. Let me start from the string copy function. Well, what I'm going to do in this, basically, this string copy, strcpy, is a function which I'm going to develop, which takes actually two arguments, two parameters, s and t, and this is actually part of the standard library in the C language. And what it does, it copies the string t, so this is the source, if you like, into string s, the destination. So basically, this function takes two arguments, source and destination, and as a result, it's gonna copy whatever characters contained in the source string into the destination string. Okay, let us see what happens if we say s equals to t. What do you think gonna happen? Okay, let's think. It copies the pointer. Well, s and t, as we already know by now, is that they are pointers that point to the first entry to the first character in the string. So it's like this, like the P message in here. It's something like this. Here's S, and here's my string, my actual string. But that's S. And down here, somewhere, maybe, I have T. So S and T are actually pointers to block of characters or to strings. So when I say something like S equals to T, what I'm basically doing, I'm reassigning, as a matter of fact, S to point to this. So I'm not copying actually physically the string. I'm just making both pointers to point to the same physical memory location. Is that what you want? Well, it depends. If you want to physically copy the block of data to another location, then this is not exactly what you want. You want physically to make a mirror image of this block of characters and place it at this location. If that is what you want, then this assignment in here is not what exactly you're aiming at. And that's why we have to do something else. We need to copy the characters themselves. How to do that? Well, as I said, in standard C, we don't have string functions, but rather we have lots of character functions. So basically, the string is nothing but a collection of characters contiguous in memory. So what I can do, I can just start at the very first character in my string and loop. Each time in the loop, I go to the next character and make the operation. The operation in hand here is to copy it, move it from wherever it is now at source, and make a copy of it at destination. Okay, so you start from the first one, right? And you make a copy, and there is a function to where you can put the character anywhere you like. Okay, and then you advance your pointer to point to the next character, and you loop, you transfer, you loop, advance your counter or your pointer, and you copy, and so forth till you reach the end of the string. Where is the end of the string? Well, it is the null character, as we know. So basically, the loop needs to go again and again till it encounters the null character. Each time it goes in the loop, it copies from the source location to the destination locations. There are two ways of doing this. We can do it by accessing the string as an array, like the A message array pointer we defined earlier, or by pointer like the P message. We're going to see both implementations and we're going to comment on both of them. Here's the array version. strcpy, copy T to S, and it's array basically subscript version. So basically, I'm not going to return anything as an outcome of this function. However, I'm going to basically copy whatever in T into S. And that's why I'm passing by pointer. And we know why we need that by pointer, not by value, because actually the content in here is going to change. Okay, and then I'm going to use an I, which is an integer, as a counter on the way. And then this is going to be an index to the array, which carries actually the character string. And then this is my loop, basically. I'm going to loop all over all characters that I see in the string till I encounter the null character. So basically I say, while S of I equals T of I. So I'm transferring, I'm making an assignment in here to go whatever character I have at T, position I, place it at S, position I, as long as while not equal to null. Okay? And each time I increment my index to go to the next character. And that's basically it. Okay? Let's look at the pointer version. Well, very similar. Again, I'm going to be passing both the T and S pointers to the source and destination. Again, using this loop in here, the while loop. I don't need any index in here. Well, simply because I'm not talking to an array, but rather I'm talking to the pointers themselves. So basically, what I'm saying, copy whatever content pointed by T to whatever location pointed by S. So the content pointed by S is going to be assigned according to the content in here. Do that as long as I don't encounter the null character. And each time, increment your pointer, source and destination pointers. So S and T start at the very beginning, and each time I take whatever pointed by T, put it in whatever address pointed by S, and then I increment both counters, both pointers to go to the next location and so forth. I keep incrementing till I encounter the null character, and that's where I terminate my loop. Here's another way of writing or of saying the same thing using pointers. Well, it's more compact this time. Well, it's exactly the same as a matter of fact, but instead of having an explicit increment down here in the loop, I'm doing that inside the loop, and this is post increment, as you all know, and you know this from C. So first, I'm gonna make the copy and then increment this counter, increment this counter, increment this pointer, increment this pointer. Keep doing this until you encounter the null character. So this is a more compact version of the pointer version of the string copy, but basically it's the same. Okay, let's look at some comments and conclusions in here. In both versions, the characters T in T are copied into S. Yes, whether I'm talking about the array version or the pointer version. In conclusion, I took whatever characters I have pointed by T and made a copy of them at S. Then they get incremented each time in the loop. The characters are compared against the null character, and that's the terminating condition. I mean, keep looping, whether we're talking about the array version or the pointer version. In both versions, we keep going, we keep iterating in the loop till I encounter this character. So this is pretty much the same for both versions. The effect is that characters are copied from T to S up to and including the terminating character, which is the null character. Well, this comparison is actually redundant since the question is merely whether the expression is zero. And actually, I can skip copying this null character because anyway, since the variables are of type character pointer, whether array or pointer, then that /0 is going to be added anyway. So what I can do is something like this: string copy, source, destination, and then just say this. And this is basically is going to go all over this, and it's going to definitely exit once it encounters the zero character. And that's the termination condition. So I don't have to check at the very end for the null character. However, I recommend usually to do that check, although it's redundant, so that the reader will understand much easier where you're hitting and where you're going to terminate. The string copy is in the standard library, and actually it's in the string.h library function. However, this is not part of the ANSYS C, but it has been added later on, and most compilers nowadays has it. So if you're using the compiler from Borland, the Borland C compiler, it has it. The Visual C compiler from Microsoft has it, and I believe most compilers have that as well. It returns the target string as its function value. string compare. This is another function. In this, what I would like to do is to compare two strings and to say if they're equal, or if string 1 is greater than string 2. We mean by greater or less that the ASCII code of the first string is greater than the second, or vice versa. So the string compare compares character strings in S and T. The result, negative if S is lexicographically less than T, 0 if they're equal, positive if S is greater than T. We have seen this function actually before. I'm just repeating it in here for the heck of completion of the string class. String compare compares character strings, and these are the return value. Let's look at an example very quickly, and we have seen this example before. Let's say I have these two strings. S contains the word course, and T contains the word courses. Actually, these two strings are not equal. And obviously, this one is larger than this one because it has this extra character, which is as compared to this, its counterpart in the other string, the S is larger than this one. Okay. So the way I'm going to do it, I'm going to be comparing the first character with the first character first, and then go to the next character. Okay, they're equal. Keep going as long as the characters are equal, till actually you get to the end, or actually you get to wherever you have a difference, and then you terminate your loop and return that difference. The implementation, pointer version. We have seen this actually in the previous class in lesson 3. Basically, I'm going to keep going, and each time I will check if the two characters pointed by S and T are the same. If that is the case, increment. Okay? If I encounter the null, then I'm done. And all characters so far are equal, then return 0. So the return value of 0 means the two strings are equal. Otherwise, then there is a difference now, and I terminated the loop. Then what I'm going to do, I'm just going to return the difference between the two strings. So if S is greater, then I will have some positive value here. If T is greater, then I'm going to have a negative value in here, and that's basically the return value I'm looking for. The same thing, but this time for the for the array version. So the only difference in the two implementations is that I'm referring to this. I'm defining this I, starting from 0, and using I as the index for my array, and each time I increment this index. Each time I'm comparing is I against null. So if everything is all right and I reached null and all the time these two characters were equal, then I return 0. Otherwise, there is a difference between the two, and I'm going to return that difference to basically to be my return value for the function. Okay, so that's pretty much what I would like to talk in this class about strings and string functions. However, there are many applications to where you would like to count number of characters, for example, contained in a string, count number of words contained in a string, or if you would like a number of, like comparing if searching for a certain word in a text and stuff like that. Well, these exercises and many others and other supporting material could be found on the internet in the UNINETTUNO website. And where you click on the MidNetU project link, and you can find the material you would like to see. Thank you very much, and I will see you next class.